Hello, in this video we are going to be reviewing oxidation reduction reactions. So an oxidation reduction reaction, or a redox reaction, is a reaction where electrons are transferred from one element to another. So the oxidation states are going to be changed. We have the two parts of our redox reaction, the oxidation. This is our loss of electrons. And our reduction, which is the gain of electrons. With oxidation, when an element loses electrons, or ion loses electrons, it becomes more positive. And then when a species, an element, gains electrons, it becomes more negative. Okay, so some pneumatic devices that can help you out with this is oil rig, or Leo says GER. So oil rig is oxidation, is loss of electrons, reduction is gain. And again, we're talking about with respects to electrons. Leo says GER, lose electrons oxidations, gain electrons reductions. So, pretty easy. So here's just some, a visual showing what oxidation and reduction is. Here, as we become more positive or less negative, that's oxidation. As we become more negative, reduction. So, a lot of times to figure out if a species has been oxidized or reduced, we look at what's called the oxidation state. So it is the perceived charge of an element in a compound, assuming that that compound is ionic. So you assume it's an ionic in nature. And even though not all the species we're going to be looking at are ionic compounds, it's an easy way of doing it. It's showing, whatever is most electronegative is going to take the electrons, and the things that is less electronegative is going to give up electrons. So assume all electrons are transferred to the more electronegative atom, and that the more electropositive atom does not. So electrons are assumed to transfer to the more electronegative atom, instead of being shared. Okay, so keep in mind our electronegativity trend. It goes up as we go across our periodic table. It goes up as we go up our periodic table. So, looking at the rules to determine an oxidation state. If you follow this, you'll be able to determine your oxidation state all the time. First one. Any atom in its elemental state has an oxidation state or number of 0. Okay. If we have something that is a monoatomic ion, the oxidation state is identical to the charge of that ion. And then keep in mind that the sum of all oxidation states of the element or compound, or all the elements in the compound or polyatomic ion, must equal the overall charge of the compound or ion. Okay. After we've done this, we're going to look at the hierarchy of elements. So, what take precedence for an oxidation state? The first is our group 1 metals are always going to be +1. Group 2 metals, +2 if they're not in sorry, not in their elemental form. So these are all in compounds. So okay, fluorine will always be -1. Hydrogen will be +1 unless it is grouped with group 1 or group 2. So that would be the hydride, so it would be a negative charge instead. Oxygen is equal to -2. Again, unless a earlier thing takes precedence. The rest of the halogens will be equal to -1. The rest of our chalcogenides, our oxygen group, will be -2, and the pycnogens, our nitrogen group, okay, so you'll start at the top, but keep in mind that this takes precedence over anything else. So first, we need to make sure that our compound's oxidation state will equal overall what the compound or molecule charge is. Compound or ion charge is. Okay. Let's try a couple. So we've got Cl2. If we look, Cl2 is in its elemental form. So because it's elemental, Cl will be 0. CO2, oxygen is the thing that's going to take precedence here. Oxygen will be equal to -2. And if this portion is -2 for each oxygen. There's 2 of them. This would be equal to -4. So this has to be +4. SO2 minus, our oxygen is taking precedence, so oxygen would be -2. So this portion right here is -8. And our overall charge needs to be -2. So our sulfur here will be +6. And then H2O2, the hydrogen is going to take precedence. The hydrogen is +1. So this portion is +2. So this portion must be -2. We have 2 of them. So each oxygen would be -1. Okay. You guys, I would like you to try this on your own. See if you can get the oxidation states for all of these. They're on the PowerPoint if you want to check your answers. Okay. Next we're going to look at oxidation and reducing agents. So an oxidizing agent is something that's going to oxidize something else. So it causes the oxidation of another species. So it's not a species that gets oxidized, it causes the oxidation. So this has to be the thing that is being reduced. So this is the compound or species that contains the element that is being reduced. As a side note, something that is oxidized or something reduced, that'll be a single element. A oxidizing agent would be a compound, or the full thing. Okay, our reducing agent causes the reduction of another species. So it's going to contain the element that is being oxidized. Okay. So, elements and atoms are oxidized or reduced. Compounds with our element or atom are oxidizing and reducing agents. Okay. So, when we're looking to try and figure out if we have a redox reaction, the first thing we should do is look and see if we've got anything changing oxidation state. So, in any redox reaction, two elements will change oxidation state when going from reactants to products. Okay, so an easy way to do a redox reaction is looking at what species are being oxidized, what species are being reduced, and then you can start to produce your half reactions. And we're going to talk about actually balancing these redox reactions in the next video. But keep in mind, if you see things that are going from elemental form to compound form, a lot of times that will be a pretty good indicator that you have a redox reaction. Metals are oftentimes involved, so that's another pretty good indicator. But almost always, you'll be able to determine if a species is or if a reaction is a redox reaction. Okay, that's it for this video. We will continue on with chapter 20 in a further video. Bye.